The sun is a massive dynamic place. Its impact is felt across the solar system. 3 new missions are going to help us understand our star like never before. They will monitor the sun's effects from up close out to the edges of the solar system.
We need to understand how our own home in the galaxy was created.
Every time we've gone someplace new, we've been surprised.
We expect there to be great discoveries of things we can't even envision today.
On September 24th, 2025, a SpaceX Falcon 9 rocket lifted off from Kennedy Space Center in Florida, carrying 3 scientific spacecraft on a mission to explore the sun's power and its effects across the solar system. The launch unfolded flawlessly.
Good looking flight so far. Our tracking cameras getting a great shot as this mission climbs into the sky. We'll be looking now for those engines to throttle down as we go through max Q, the time of maximum dynamic pressure on the vehicle.
Falcon 9 power and telemetry are nominal.
That's right, so coming up is max Q, which is the maximum aerodynamic pressure, largest structural load the vehicle will experience. So slowing it down helps to reduce some of the load it experiences.
Falcon 9 is supersonic.
And that will help us recover and reuse the first stage. Following max Q, we'll be able to throttle those engines back up as atmospheric density drops.
Max Q.
First, NASA's Interstellar Mapping and Acceleration Probe, or IMAP, separated from the rocket. IMAP is the flagship of this mission. Equipped with 10 instruments, it will investigate the solar wind, the steady flow of charged particles streaming from the sun. By mapping these particles and the radiation they carry, IMAP will help define the boundary of the heliosphere, the protective bubble that surrounds our solar system. Understanding this region is vital, not just for science, but also for keeping future astronauts safe as they travel beyond Earth's protective magnetic field. Then, NOAA's Space Weather Follow On satellite deployed. The Carruthers Geocorona Observatory focuses much closer to home. This small satellite will study Earth's outermost atmosphere, called the Geocorona. This region glows faintly in ultraviolet light and represents the edge where our planet's atmosphere fades into space. By observing it, scientists can learn how solar activity influences the boundary between Earth and space. The third spacecraft, NOAA's Space Weather Follow On at Lagrange Point 1, has a practical mission: protection. It will monitor solar storms, bursts of energy and particles from the sun that can disrupt satellites, threaten astronauts, and even damage power grids on Earth. Acting as an early warning system, SWFOL-1 will give us the time needed to prepare for dangerous space weather events. All 3 spacecraft will travel to the same destination, the Sun-Earth Lagrange Point 1, located about 1.5 million kilometers from Earth. From this stable perch between Earth and the Sun, they'll have an uninterrupted view of solar activity. Together, these missions form a powerful trio. IMAP will push the boundaries of heliophysics. CGO will explore Earth's atmospheric frontier, and SWFOL-1 will stand guard against solar storms. Moments later, the Falcon 9 booster returned safely to the drone ship Just Read the Instructions, marking another successful landing.
Stage 1 landing confirmed.
Beautiful touchdown there of the first stage, and that marks the second landing for this booster.
I must say that never gets old.
No doubt. And now, the stack. You can see it's not quite illuminated incredibly well, but up there is IMAP, Carruthers, and SWFO L1. We will continue to monitor the progress during coast phase.